Avem conexiune în direct cu NASA, o să am nevoie un pic și de sunet aici, pe laptop. Ecranul nu merge, o să merg. Legătura în direct cu Anthony Scodary, Instrument System Engineer la Jet Propulsion Laboratory, NASA, California. Hello Anthony, can you hear us? Anthony? Asta e momentul ăla cu surprize, știți cum e, când se așteaptă aterizarea. 7 secunde. Okay, so let's try again. I will remake the connection. Probably there is a slow connection. We'll try again.
Yeah.
Okay. Now we can switch to video.
All right. Do you hear me okay?
Yes, we can hear you. Hello, Anthony. Welcome.
Thank you.
Okay, can we switch to video to see you?
One moment here. How's that?
Great. Welcome to Atlantykron.
Hello, Anthony. Everybody.
So, we are very glad and enthusiastic to have you here. We understand we have some questions about you. I will present first the hosts. First on the left is Sorin Muntanu.
Hi.
Hi.
Nice to see you, and it's an honor for us to have you here.
Sorin Repanovici, I'm in the middle here. I'm a coordinator of Atlantykron. I'm happy to host for the third evening somebody from Mars mission from the United States. Welcome again.
Thank you.
Okay, so we understand that you are mainly dealing with APXS and our EMS instruments. Can you first explain to us what are those instruments and what you are doing?
Okay. I work as one of the handful of instrument engineers on the rover, instrument systems engineers, and so in addition to doing what they call cross-cutting instrument activities, integrating the instruments and testing them, I'm also the cognizant engineer on the REMS and APXS instruments. The REMS instrument has sensors around the rover that are used to detect the weather. And so it's essentially a Martian weather station that detects a lot of the same measurements as a weather station that we might have on Earth. It detects temperature, atmospheric pressure, humidity, wind, the ultraviolet radiation from the sun, and also the ground temperature. APXS stands for Alpha Particle X-ray Spectrometer. It's a device that they place on rocks that we've flown on every mission to Mars that tells you what elements are in the rock. And it uses that by sending out X-rays from a radioactive piece of material called curium. And the X-rays bounce back, and essentially the frequency with which they bounce back in the spectrum of X-rays tells you what elements are in the rock, and so it allows you to determine composition of different types of rocks.
So did you receive any data from the instruments by now? Do we know what the weather is on Mars?
I can tell you right now that we have there are 10 instruments on the rover, and as of today, we have spoken to all 10 instruments. That is, the rover has turned them on and verified that they work. And we're still in the commissioning phase with the rover, where we're testing everything out. So that means we turn it on, see if it works. But that said, yes, we got our first spectrum from APXS today. Admittedly, it wasn't placed on a rock, so all we saw was the atmosphere, which primarily we saw argon, which is a principal component that is in the range that APXS can see. The carbon and oxygen we can't see with the instrument. And then with REMS, we turned it on a couple days ago and got our first weather measurement. And we can say that the weather on Mars is very clear, very nice, and very cold. And so the temperature so far has been between -10 and -70 Celsius, and it's very cold, even though it's not even the winter there. And so and what we'll be doing with the weather station in a couple days is the weather station will be on 24 hours a day, around the clock, taking weather measurements day and night. Right now the instrument is off, and it won't be turned on for another 4 days. We only turned it on briefly to make sure it was alive, and that goes for a lot of the other instruments. And so the idea is, we just landed Sunday night, as I'm sure you learned from the other speakers, and now that we're done with landing, the people who designed and built the rover, including myself, are trying to test out the rover very slowly to make sure that it's working properly. And part of that involves turning things on one at a time, looking for basic signatures that the device is operating. And so there's 10 scientific instruments, and we're first just using them for very basic things, and then down the road we'll be using them for more and more advanced tasks. And eventually we'll the engineers will essentially hand over the keys of the rover to the scientists, who will then be able to begin more and more complex scientific investigations.
Thank you very much. My name is Sorin, and what can I tell you? I'm so exciting. I had the chance to be in Pasadena, let's say, some years ago, where Pathfinder landed on Mars. So, in a way, it's a sort of, I know how exciting are these days for you, and being a researcher too, I'm so involved in this domain of new and so on, that I have so many questions, but I have passion to put questions perhaps in another domain on another time. At this moment I want to intermediate some questions with the guys that are in front of us, and they want to put questions for you because they are very excited about this event. So if you have some questions for Anthony, please do it now.
Hi, Sorin speaking, Anthony. About that famous 7 minutes of terror, right? Just a few days ago. Okay, you have a satisfaction, everything was okay after that 7 minutes. How about you? You have any emotions? Maybe the instrument doesn't work properly. How you feel after the instrument send the information and you receive information from them?
That's a great question. So he's asking, how do we feel after making sure the instruments have survived entry, descent, and landing? And I mean, yeah, it's very emotional, very exciting. I can say that there are two critical events in this mission, right? The first one is launch, and the second one is EDL. And they're both critical in the sense that there's a lot of high risk in one very small amount of time, which can make it more stressful and also more exciting. And so I can say that after launch, we, just like we do after landing, we do a series of what they call cruise checkouts. And that is, we turn on the instruments briefly while the rover is in space going between Earth and Mars. And we make sure that they survive launch. And I can say that there are cases in the past where instruments have not survived launch. And so it's not only relieving, it's very happy when your instrument starts working. The whole team that is behind each scientific investigation for each instrument is very relieved, very excited. But when you do it for the first time after landing, it's even more so. And the reason is you've gotten past those critical gates. You are now on Mars, ready to do science. And so for us people on the rover team, on the surface team, surviving EDL is very exciting to us, and admittedly, there's still hard things to go. We haven't driven yet. We haven't unstowed the robotic arm yet. A lot of the more complex instruments, like Caton, which does mineralogy, or SAM, which is looking for organic molecules and the signs of life. Those instruments and those engineering functions are still very high risk, and we don't know for certain if they're going to work yet, since we've landed. And so, we're very confident. We've done a lot of testing. But that said, you never know for sure when you're doing something for the first time. And some of the most complex operations we will ever do, which include, for instance, the robotic arm has the ability to actually change drill bits if necessary. And there's never been a robotic tool change on another planet. And so a lot of these what they call first-time activities are just as stressful as the 7 minutes of terror. And so it's right now in the commissioning period where we're doing everything is new on the surface of Mars. It's a lot of little 7 minutes of terror for every little team on the rover. And so, for instance, today, we did the first spectrum from APXS, and now that it worked, we're very excited, very relieved, and that goes for the rest of the instruments, all of which we've talked to now.
Thank you. To understand better, you have more than 7 minutes of terror, because you need to wait more and more emotions. I tried to understand what was in your heart. You worked so much for this project, and finally you have a success. Once again, congratulations. Also, we want to let you know that we have American friends here. We have people from Washington, we have people from Tennessee. They say hello to you. Of course, some European friends from Italy, from France. Also, they say hello to you. We continue. If you don't mind, we continue with the questions.
So we're trying actually to imagine if a live video transmission will be possible in the near future from a rover like Curiosity. So that's why I have a question. What is the maximum bandwidth transfer rate that Curiosity is capable to send to Earth?
Okay, that is a great question. So there are several what we call critical constraints on the rover, which are capabilities that limit what we're able to do. And so one of those is we have limited power. The RTG, the radioisotope generator that we have on the rover can only produce so much power a day. And so we can't just run the ovens on the SAM instruments all day, for instance. But another one of the big constraints, as was mentioned in the question, is bandwidth. How much data can we get down from the rover to Earth? And I can say that most of the data that we send back from Mars does not actually go direct to Earth. It actually goes through two orbiters that are orbiting Mars, the Mars Reconnaissance Orbiter and the Mars Odyssey Orbiter. And those two orbiters are satellites that are going around Mars, pass over roughly every 2 hours. And so about 4 times a day, the rover sends data to these orbiters, and then the orbiters stores the data and then sends it back to Earth when it sees Earth again. And they call these passes, or UHF passes. UHF is the band of frequency where the downlink normally happens. And I can say that it's very limited. It can be up as fast as 2 megabits per second, which is actually, compared to your internet connection, not terrible. But it's only for 10 minutes at a time, and it's only about 4 times a day. So imagine how much data. Sometimes it's less than 10 minutes. It's sometimes more like 5. And so imagine if you had the capability to download what is the equivalent of maybe 15 images of data a day. And you can't just download images, you need to download engineering data, health data, and spectra, data from other instruments, thermal data, temperatures, and other health metrics that we keep on the rover. You find out very quickly you run out of bandwidth. And so that is one of the reasons that we haven't had, for instance, something like a live video feed like you asked for asked about in the question. Is it possible in the future that we'll ever have a live video feed? Well, yes and no. No in the most literal sense, in that light travels at a fixed speed. And so right now, the time it takes a signal to go from Mars to Earth is 14 minutes. And it can get as long as 20. And that's never going to get better. It's a law of physics. And so we're never going to have live, like for example, the Voyager spacecraft, the 2 Voyager spacecraft that have essentially left the solar system at this point, takes hours for the data to come, just to travel at the speed of light. But if you just want to know, will we ever have enough bandwidth to get a live video feed, even with the delay? The answer is maybe yes. I mean, certainly if we had enough funding to build that infrastructure. However, it would be very challenging to do so. Things that have been proposed include laser transmission, where you send data over a focused laser. And one of the benefits of laser, what they call optical communication, is that because laser light is collimated, or it means it stays in a narrow beam, it doesn't lose as much energy. And so you can send it at a greater distance with more data, and maybe you could get that to work to the point that that you could do something like a live video feed. And there are talks of future Mars missions, maybe even in the next 10 years, of attempting laser communication. And you know, if it works well enough, then maybe we'll see, even for just portions of the day when Earth is in the field of view of that, wherever your lander is on Mars, you could have something like a live video feed. And that would be very exciting, because even if you don't end up using it all the time for a live video feed, it also means more scientific data, which means that you can take more complex measurements and get more data down to Earth. And that, like I said, is a critical constraint, how much data you have, just like how much power you have. And that's a big driver for how much science you get done.
So I can see that the anxious moments waiting for the pictures to come from the curiosity never ends until the end of the mission.
That's what we spend a lot of our time doing, and we have what we call decisional data, which is data that is so important that it will drive our decisions for the next day. So let's say we had 2 images. One is of our wheels to tell us if we're able to drive, and another image that's of a mountain. The picture of the mountain could be the picture that is prettier or more useful for science, but it actually doesn't drive what we do the next day, because we know we're going to get that picture of the mountain down eventually. And so what we do is all the data on the rover has a number. Every single picture, every little measurement has a number associated with it, which is a priority. It's a number 1 to 100. And the rover has what's called a queue, where it stores all the data, and when it sends data to the orbiters or to Earth, it will only send the highest priority data. And so every day, part of our decision making is prioritizing literally every single data that we're going to generate. And some of it's autonomously, prioritized if we didn't expect the data to be generated. But what that means is the picture of the wheels that we need to drive, because it's going to drive our decision to drive or not drive the next day, will have a higher priority and will probably come down very shortly after it's taken, right? Whereas the scientific image that's less important but maybe more beautiful won't come down for maybe another 12 hours. And that's typical. That we see that every day. And if you actually have been following the rover since it landed, you'll see some of the data. First, we had low resolution, very blurry images, and then a day later, we have very nice images. And so, for example, yesterday, we got the first black and white panorama, but only in what they call thumbnails, little images, and it was very blurry. Today, we got down the full thing, right? It came down because it was non-decisional to get down the full resolution image, so it came down later. But today, we got the first color panorama, and that's now very blurry and pixelated, and that one could actually take days to get down because the color images are bigger and higher resolution. So,
we were very enthusiastic to see that image, and send many thanks to all the NASA team there for sharing the pictures from curiosity to us. We have another special guest, it's near me, that wants to put